Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Did you remember what were we discussing yesterday? I think we were discussing about retrosynthetic analysis and its application. So what are the terms used in the retrosynthesis we have learned so far, and now today we are going to learn the actual application of that retrosynthetic analysis. And before starting the application of the retrosynthetic analysis, let me recap, let me revise, let me tell about that terminologies. Once again over here, one we are using, first one is a RSA. RSA means retrosynthetic analysis. Retrosynthetic analysis means what? The process of breaking down target molecule into convenient starting material using disconnection and functional group interconversion is known as a retrosynthetic analysis. Second term we have used, that is a RS. RS, the full form of RS is a retrosynthesis. Retrosynthesis means what? Definition: an imaginary but logical reverse chemical reaction which help us to reach the reactant starting from the target molecule is known as retrosynthesis. And next one we have seen as a TM. TM is nothing but as a target molecule. The molecule whose synthesis being planned is called as target molecule, and they are represented like the framework, like TM1, TM2, TM, etc. And then fourth one we have learned, what is that? D stand for disconnection, and symbol of that disconnection is a double line and then arrow headed on one side, so that is a disconnection. An analytical operation which break a bond and convert a molecule into a possible starting material is known as disconnection, and it is very important and the essential step present in that retrosynthetic analysis. And the fifth one, that is a S stand for as a synthon. Synthon means what? The reagent carrying out, synthon is a fragment of molecule which are associated with polarities is known as a synthon. After the disconnection, whatever positive and negative species are obtained are called as synthon. And next one we sixth number, that is a SE, means synthetic equivalent. AC, the full form of AC is a synthetic equivalent. Synthetic equivalent means what? A reagent carrying out the function of synthon is called as a synthetic equivalent. With the help of suitable example, we have explained that term. Each and every term I already described, I already explained to you. So just I am only definition I am telling right now here. And the seventh one is called as a reagent. Reagent means what? A compound which react to give an intermediate in the planned synthesis or target molecule itself is known as reagent, like as a sodium hydroxide, sodium ethoxide, potassium hydroxide. These are the example of reagent. And now next point I am the last point will be, means 8th point, is a FGI. The full form of that FGI is a functional group interconversion. Functional group interconversion means what? The one of the functional group converted into another functional group so that disconnection becomes possible, and generally it is written FGI over the disconnection arrow is known as functional group. These are the 8 important term term and their definition we have learned, and now we are starting the actual application of that retrosynthetic analysis. So do the retrosynthetic analysis of the following molecule, or maybe the what is the retrosynthetic equivalent, write one example of it, or write the retrosynthesis and synthesis for. Write the retrosynthesis and synthesis for. This the question generally appear for 3 mark. 1/2 mark for retrosynthetic analysis and the 1/2 mark for actual synthesis. Means write the retrosynthesis and synthesis of following molecule. Let us see here the first application. I am writing here the target molecule, which is a very important one. How the actual, once you know that first one, let us see, suppose here this is our target molecule CH3, CH, then CH, here OH, and here CN. So this is our target molecule. This is a target molecule A, we can call it, or this is a target molecule 1. I am writing over here TM1. That is a TM, as we know that TM means what? The molecule whose synthesis being planned is called as a target molecule, and this is our target molecule. And the first point here is a retrosynthetic analysis. RSA means retrosynthetic analysis means we have to analyze this target molecule. As I have already told you, you observe this target molecule carefully and see how many functional groups are present there. Recognize the functional group in the target molecule and then break a bond in such a way that you should have the making of that bond, the sum of the named reaction you should have in your mind. Then and then you have to break that target molecule, otherwise no need. So let us see here, because here we are going to learn only as a one group disconnection approach, one functional group disconnection approach, one functional group disconnection arrow. But here let me tell you, here concentrate. So most of the thing you have to, as we know that alcohols generally is prepared or synthesized in the laboratory, and you might be knowing as a Grignard's reagent, right? Grignard's reagent is a reagent used for the synthesis of primary alcohol, secondary alcohol, as well as tertiary alcohol. Only few of the molecule like as a formaldehyde and the epoxide treated with Grignard's reagent, they gives primary alcohol, whereas rest other aldehydes like as acetaldehyde, propanaldehyde, benzaldehyde, whatever aldehydes are there, if you treat with the Grignard's reagent followed by hydrolysis, they produce the secondary alcohol. Remember, and tertiary alcohol, how do you prepare tertiary alcohol? If your if your target molecule has only one functional group, then and then you can approach, you can perspective or the area of there are the different aspect of that, but the first aspect is that you should recognize, you should identify the functional group. How many functional groups are present in the organic compound? There are different type of the functional groups are present, but particularly here, look at here, one is a cyanide and one is a hydroxy groups are present over there. Now I am doing as a retrosynthetic analysis. Now I am going to get here is a 1/2 mark. Suppose question is there 3 mark question. Write the retrosynthesis and synthesis of this target molecule they will give. This is a cyanohydrin is a derivative, and the main functional group present over here is suppose as a hydroxy. How it is broken, let us see. I am writing this target molecule as it is over here. Let us see here. I am writing that target molecule CS3, then CH, then OH, then H, and then Cn. This is my target molecule, and which I am mentioning, which I am representing here is a TM1. So observe this reaction, retrosynthetic approach carefully, and after that you can do your own. That is a very, very simple one, because you are looking this in a first time, and that's why it looks as a difficult. But once you are familiar with this retrosynthetic, it is a very, very easy. You can break as a bond any, because while doing as a retrosynthesis, you can use any route, any starting material, and any sequence of the reaction. So there is no boundary for applying, for using the point, but ultimately the synthesis, the good synthesis is those that synthesis must be higher yielding, rapid, the yield is getting in a short time, then high yielding product, then eco-friendly environment, benign synthesis, minimum pollution or minimum side products. So that are the some of the criteria for the good synthesis or for ideal synthesis. But here we are just thinking logically, we are developing, we are going to develop how we can prepare this target molecule in a lab or in a first we are doing this work on the paper, and after that we are going to synthesize this in the actual in the laboratory. And this is, as we know, that disconnection arrow, how the this compound there is a alcohol is there, alcohol always breaking like this bond is forming as a double bond over there, and we are getting as a this type of the fragmentation. Let me show here CH3, then here is a CH2. I have not written over, but remember there must be as a CH2. Here CH2, so here should be as a CH2. CH3, CH2. This is a breaking like this. We are getting CH2, then C double bond O and H over here. And now another thing we are getting here is a Cn minus. Now Cn minus is nothing but as a synthon. Remember, this is a synthon, and synthon must have a synthetic equivalent, and synthetic equivalent are shown, are represented by these three arrows, and therefore here you can write as a SCN minus, and that is nothing as a synthetic equivalent. And synthetic equivalent sometime it is also called as a reagent. This is a synthetic equivalent or hydrogen cyanide. It is also referred as a reagent. And as we know that synthon means what? It is associated with the polarities, means plus and minus charge. That type of the species are called as a synthon. And synthetic equivalent means what? Synthetic equivalent means what? The compound which carrying the function of synthon is known as a synthetic equivalent. And the reagent means what? This also we can call it as a reagent. Reagent means what? A compound which react to give an intermediate, or the target molecule itself is known as a reagent. So that are the terminologies we are going to use frequently, so that you can get familiar with those words, with those terminologies. And now this is what we got. This one is a propanaldehyde we got, right? Propanaldehyde, right? And this propanaldehyde we can do here disconnection, and I am writing here is a FGI, functional group interconversion, right? And this is a disconnection arrow, written over is a FGI. Full form of FGI is a functional group interconversion, and the definition of that functional group interconversion means what? One of the functional group is converted into another functional group so that disconnection becomes possible is known as a FGI. What I am going to do over here, this propanaldehyde can be obtained from this one CH2, then CH2OH. This can be obtained from what we can call it as a N-propyl alcohol. This is N-propyl alcohol. This is a primary alcohol, and this N-propyl alcohol can be obtained from this we can do as a FGI functional group. Go on writing as a functional group interconversion. One of the functional group is converted into as another functional group so that disconnection becomes possible is known as a disconnection, is known as a functional group interconversion. So I am writing this one is over here. Let me clean this target molecule over here, and now that I am writing over here, this one is a CH3, CH double bond and CH2, and this is a what we can call it as a propene. Everybody knows that, right? Propene containing as a carbon-carbon double bond, and this propene again we can do as a functional group interconversion, and this can be obtained from CH3, CH2 and CH3. That is this is a propane, right? N-propane over here, and N-propane, which is a N-propane is a natural gas which is available in the nature, means readily available in the ultimate aim, whatever the starting material we are going to find out, that should be easily available or it is feasible, and the cost of it is very low, and we can use at ordinary so that it will give you the high yield, so that or more than 90% yield are generally known as atom economy. Atom economy means what? The maximum bond of that goes into as a maximum bond of the maximum atom are incorporated into as a final product. So that type of the terminology is known as atom economy. If you observe this retrosynthetic analysis carefully, step by step, you see over here, this is our target molecule and this is a disconnection arrow. The meaning of the disconnection arrow means this target molecule could be made from this propanaldehyde, and that propanaldehyde could be obtained, could be derived from N-propyl alcohol, and N-propyl alcohol could be prepared from propene, and propene can be obtained from N-propane, a natural gas available in nature. So this is called as retrosynthetic analysis. We have interpreted, we have analyzed this compound in a simplified way. So if you do like this, you will get 1.5 mark, because this question generally for 3 marks. So write the retrosynthesis and the synthesis of this target molecule. Okay, half work we have done over here. Now let us start. Now we got, this is our starting compound or this is our precursor. By using this we can, because retrosynthetic analysis or retrosynthesis means what? An imaginary but logical reverse chemical reaction which help us to reach the reactor starting from the target molecule is known as we arrived at the starting material. This is our starting material. We arrived at the starting material which is readily available. Cost of that material, raw material, which is also very low, and now we are going to prepare, we are going to synthesize the molecule now. Remember the sequence here. Now I don't have a space over here, so now I am going to synthesize this compound. Half of the part is done over here. Now is a second part I am starting the synthesis over here. Let us see the how I am going to synthesize this. Last means final. Now I am going to start from the synthesis, start from the starting material or the reactant. And what the reactant we got here, starting material is this one, CH3, CH2 and the CH3, right? This is the starting material. The name of this compound is a N-propane, right? N-propane is a N-propane we got here. And now the simple arrow. The meaning of that arrow, we know that the simple reaction arrow, this represent react to give. When it react, if you treat this compound at 400 degrees centigrade in presence of palladium, palladium is a catalyst. There during the cracking process, what is going to happen, this propane is converted. This is one of the method for the preparation for the synthesis of alkane to alkene. Remember this one. And now what you are going to get, CH3, CH double bond and this CH2, right? So likewise you get over here is a propene, right? The name of this compound is a propene over here, propene, right? CH3, CH double bond, CH2, we got the propene. After that, this now N-propanol, right? Now what will be the reagent you will use over here so that you will get as because we are going reverse now. We are going backward now, starting from the target molecule. So here the reverse. Now tell me, how do you prepare this? The compound CH3, CH2, CH2 and OH. Because these type of the alcohol you have prepared, you have obtained, you have derived, you have learned this type of the molecule, how to make that molecule by using as a different method, by using as a different oxidizing reagent you have learned, different reducing reagent you have learned. Again you have learned what we have learned, different naming, different famous reaction you have, different rearrangement reaction you have learned. So by applying your previous knowledge here at appropriate position, tell me what is the reagent which convert propene into as a alcohol. Because in FY-B.Sc you might have learned in SY also or in your previous classes. So that is a alkane. Have you heard about because this is one of the method of preparation of alcohol using as a starting from alkene, right? That is a method. And if you let me give some clue over here. Have you heard about hydroboration reaction? Yes. Hydroboration reaction, what are the reagent you are using and what would be the resulting product or the final product you are getting, because your starting material is alkene. If you do the hydroboration oxidation reaction, which is one of the famous reaction, which is the reaction where you can synthesize, you are preparing the alcohol, and that alcohol is obtained according to as anti-Markovnikov rule. Remember, anti-Markovnikov's rule means what? You have learned the Markovnikov's rule anti-Markovnikov's rule in your previous classes, right? Markovnikov's rule, it is definitely related to as an addition reaction. Now in an addition reaction, negative part of the reagent attached to those carbon atom which carries more number of which carries less number of hydrogen atom. That is that type of the rule says the Markovnikov's rule, and exactly opposite to that is called as anti-Markovnikov's rule. And let me tell you one more example while writing as a mechanism are involving, or mechanisms are proceeding via two ways. One way is a ionic and second way is a free radical mechanism. One is called as a ionic mechanism, another one is called as a free. Only two kind of the mechanisms are present in every organic chemistry, in every organic reactions. So here those are recall their memory, then they will find the reagent, which reagent they are using in a hydroboration oxidation reaction. Most of you might be knowing that is a B2S6 in presence of THF, and second one is a H2O2 in presence of OH minus. This process is known as a oxidation hydroboration oxidation reaction. Hydroboration oxidation reaction, and this is one of the best method for the synthesis of primary alcohol or the alcohol from anti-Markovnikov's rule. Now, and they look at here what the anti-Markovnikov's rule says, that in an addition reaction, negative part of the addendum attached to those carbon atom which carries the more number of hydrogen atom. If you observe this alkene over here is a this carbon atom carrying one hydrogen atom, but this terminal carbon carrying as a two hydrogen atom, and therefore the reagent which is the negative part means OH minus is there, and that OH minus should attach to those carbon atom which carries as a more number of hydrogen atom, and therefore we got as a this type of the product over there. This is a N-propyl alcohol. N-propyl alcohol. This is the N-propyl alcohol we got over here, right? Now this we are going to prepare this by using some proper or the appropriate specific reagent you have to use over there, and you are going to get here CH3, then CH2, CH2, then here C double bond O and the H, right? This is one, two, three carbon atoms are there. So that is a propanaldehyde, right? Propanaldehyde. Do you remember? This is a primary alcohol, and that primary alcohol should be converted into as a what we can call it as aldehyde. What will be the suitable reagent over here? So most of the in the book also shown they are used as a K2Cr2O7 in presence of the H2SO4, that is a zoned reagent, but that is a strong oxidizing reagent. What it will do, it will convert that primary alcohol into as a carboxylic group. We want to stop the oxidation at aldehydic stage only, and therefore they in a SY-B.Sc. I think you have learned one chapter. There is a functional group interconversion. So many functional group you have converted into as another functional group by using the specific reagent, and we got the that one. So apply that rule or apply that reagent, that knowledge over here, and there is a oxidation, no doubt about it over here. That primary oxidation in terms of the organic chemistry, oxidation means what? Removal of hydrogen atom, or in another way addition of oxygen atom is known as a oxidation reaction. And the reduction means what? Addition of hydrogen atom or removal of oxygen atom is called as a reduction. So these are the term or the definition related to as a oxidation and the reduction corresponding to organic chemistry. There are oxidation and the reduction term used in the organic chemistry, used in the inorganic chemistry, that is related with the electron. Loss of electron is called as oxidation and the gain of electron is called as a reduction. So simple definition they have used in the inorganic chemistry, but here in the organic chemistry, the oxidation, there are different definition is used in the organic chemistry, but let me tell you simplest definition for the oxidation means removal of hydrogen atom from the substrate, from the starting material or from the reactant is called as a oxidation, and reduction means what? Vice versa or exactly opposite to that, addition of hydrogen is known as a reduction. So that's it. Now we got the propanaldehyde, but tell me that is called as a PCC. Have you heard about PCC? Pyridium chlorochromate. This is known as a pyridium chlorochromate. Pyridium chlorochromate. This is how do you prepare that pyridium chlorochromate in the laboratory? Very easily in the test tube you can freshly prepare that pyridium chlorochromate. What is the full form of PCC is the pyridinium chlorochromate, right? And now the preparation of that preparation is very easy. Preparation of PCC. In short, I am showing over here preparation of PCC. But here, how do you prepare that PCC? You might be knowing this is a structure I am writing over here. What is the name of this structure? It is a pyridine. Everybody knows that, right? This is a structure of pyridine. Pyridine, which is acidic in nature or basic in nature. Most of you know that this is a basic in nature. Why it is a basic in nature? In general statement you remember regarding as organic compound, those organic compound containing nitrogen atom are basic in nature because nitrogen atom containing lone pair of electron, according to as a Lewis acid base theory, it can donate the lone pair, and that's why it is a basic in nature. Then it is treated with CrO3, chromium trioxide, and plus HCl. So these are the three reagents mixed together, resulting complex form is called as a pyridium chlorochromate, like this. So here nitrogen atom, then here is here one of that hydrogen atom, therefore positive charge, Cl minus, here you can write CrO3 and Cl minus. This type of the salt or this type of the reagent is called as a PCC. This is a PCC, pyridium. This is a pyridian. IUME indicate as a positive charge on that nitrogen atom. Chloro means chlorium, chlorochromate. CrO3 is called as a chromate. So this is a pyridium chlorochromate. It is a very proper reagent which convert primary alcohol into as a aldehyde. And now let us see over here what is the next point I am going to discuss over here. The finally what you are going to get over here, finally this propanaldehyde is treated with hydrogen cyanide or sodium cyanide. You will get your target molecule. right? Target molecule, which is target molecule we got over here, Cn minus is attacking over there, and you are going to get your target molecule, this one CH3, then CH2, COH, H over here, and this is your target molecule. Got it? This is your target molecule first. So in this way we can prepare, we can synthesize the target molecule in in this fashion. Now another molecule we can take over here, second application for the synthesis of, but here let me tell you, these are the some of the different what we can call it as a different method, whatever different function terminologies we have used here, that we have repeated again over here. And now I think with this let us stop today here. Remaining application, remaining target molecules, retrosynthetic analysis and its application, we will see in the next lecture. Let us stop today here. Have a nice day. Thank you.